Welcome to Configuring ScreenOS Firewalls. This is the session on transparent mode. Transparent mode is the special operating mode for ScreenOS where you can insert the device into an existing layer 3 network and not make any IP changes at all in the architecture. So the objectives for this chapter then are to be able to describe the advantages of transparent mode and how it operates, to be able to distinguish between the transparent mode zones interfaces and the layer 3 mode zones and interfaces when you're looking at the configuration of a ScreenOS device. And to be able to use the VLAN 1 interface and configure this for management of the device that's been configured in transparent mode. The VLAN 1 interface is a special purpose interface just for this operation in transparent mode. So the session here is divided into 3 sections. First, we're going to go through a description of what transparent mode is and where it would be applicable as a deploy option for ScreenOS. Then we'll go into how you configure transparent mode on the ScreenOS devices and how it differs from standard configurations. And then we'll go through the commands you can use to verify transparent mode operations on a configured and operating device. Transparent mode is the ability to insert the ScreenOS device in between existing devices on a layer 3 network. So in this diagram here, we have the Juniper ScreenOS device in the middle, and we have 2 layer 3 routers or switches in a network with a bunch of computers. And we can see that the Juniper device overlaps partially devices in or sections of each of those 2 devices and creates an address space that the Juniper device operates in a single broadcast domain. So the interface mode in transparent mode, everything is working as a bridge at layer 2, all the interfaces that are in transparent zones. Which means then we're doing our standard layer 2 type operations. We're learning MAC addresses, we're flooding them, we're forwarding them, and we're able to filter based on switching rules. But in addition to these standard layer 2 operations, you also then have the rules of policy, meaning you can control traffic based on policy rules coming between 2 devices in the same layer 2 zone when the traffic comes across the ScreenOS device. So this allows you to insert a policy engine into a layer 2 network. So where would you need to use this? If you need to insert a firewall into an existing layer 3 zone. A common example would be you have a public segment where all the servers have public IP addresses, they're connected directly to the public network, and perhaps they're only protected at this point by router-based access control lists instead of a full-fledged firewall. You can keep the IP scheme, the public addressing, not introduce any NAT or anything into the picture, but still apply firewall rules in the situation. Therefore, you don't need to redesign the layout of the network to insert the firewall. You know, the layer 3 network can remain exactly as it is. And you don't have to change the IP space. So normally when you take a public server segment like that and move it behind a firewall, you're going to have to re-IP all the servers, put them into a private network and zone and set up all the NATing and everything behind the firewall. you can avoid all those operations by inserting the firewall instead in this transparent mode. So you're able to improve the security of your server segment that may be protected just with router-based access control lists by inserting a full-fledged policy firewall without having to make any of those major network changes. The transparent device is also capable of terminating a VPN connection. So if for some reason you need to create a VPN from this segment you're in to another device, you can still do full-fledged IPsec VPN connections off of a transparent device. There is still some address translation available. You can do source address translation with a firewall in transparent mode. This will be configured using the DIP method that was reviewed in the address translation session. And you're going to be using this on the VLAN interface, that special VLAN 1 interface that's configured on the device. And when you create the DIP, you will have to use that extended interface option, because the IP address for the translation will no doubt be outside the broadcast domain that you're inserting in layer 2. Okay, so in layer 2 you still have security zones, and interfaces still belong to their security zone. So the hierarchical nature of ScreenOS is still at play. The interface is assigned to the zone in layer 2 mode or transparent mode. There are 3 predefined layer 2 zones. They are prefixed by the V1 designator, so V1-trust, V1-untrust, and V1-DMZ are existing zones that are in the system. You can create user-defined zones in layer 2 mode, and then when you do this, you need to prefix the name of the zone with the letter L and the number 2 dash. So you create a custom zone. It's L2-custom will be your zone name. So when interfaces are in transparent mode, you can have multiple zones and interfaces assigned to the same zone or different zone. The important thing, though, about the network design is that in transparent mode, you are in a single broadcast domain. So you're assigning an interface to the layer 2 zone, and just like you do any other configuration, but all of the zones and all of the interfaces have to have a common address space and be in the same broadcast domain. So that's the restriction. In this case, we're just showing 10.1.0.016. So every device that the traffic is transiting the ScreenOS device is going to be in this broadcast domain. The special interface VLAN 1 is a logical layer 3 interface to use to manage the device. So this essentially allows you to have an IP address on a otherwise operating as a switch. So the IP address will be used to connect to a device and put the ScreenOS device onto the network. It has to be in the same subnet that the rest of the transparent zones are in. So everything has to be in that same subnet. We are operating at layer 2 mode as a switch, same broadcast domain. So our management IP must also exist in that. It does support the use of the manage IP functions as outlined in the earlier session on management. and all the physical interfaces will be responding to ARP and performing normal layer 2 functions, just like a regular switch. The default management behavior, VLAN 1, the special interface, is going to inherit the management options from the zone membership of the physical interface. This is a slight difference in what we had in management before. Management before was interface based, and it's still interface based on VLAN 1, so you still need to configure what management services and the management IP, etc., are on the interface VLAN 1. But in addition to that, now each zone is going to have management services options. So here's the default assignments for those existing zones: V1 Trust, DMZ, and Untrust. V1 Trust has all of the services on for the zone. Now they still have to be enabled on the interface VLAN 1 to work. It's a both and thing. So if the traffic is coming in an interface that's assigned to the V1 DMZ zone, all it can do is ping. If it's coming in through an interface that's assigned to the V1 Untrust zone, it has no access to management services. When you create a user-defined zone in transparent mode, you have to go in to the zone configuration and choose which, if any, of these services you want to allow to come to the VLAN 1 interface. By default, none of them are going to be turned on, so you have to go enable everything you want to be able to come through. If it's not on, you can't even ping from traffic sourced in the interface for that zone. So this is an additional layer that's in place on transparent mode that you don't have in normal mode. You have to enable these management services at the zone level. So to evaluate management access, to see if you're going to be able to manage the device from where you are, manager IP, as we discussed in the earlier session on management, is still available, so you can configure IP addresses as a source address, and then only those source addresses will be allowed to connect. That will be evaluated first. Then the manage IP of the destination address, which will be what you configured as the manage IP on the VLAN 1 interface. It'll be the only IP address that's available at all in transparent mode. Then the service check is third on the source interface in the layer 2 zone. So wherever that signal's coming in, it's in a valid manager IP source. It is coming to the destination address of the manage IP on the VLAN. Now it also has to be using a service that's allowed by the interface in the zone, not the destination interface VLAN 1, but the interface in the zone that's our ingress interface for this traffic. And then finally, the authentication username and password are all still active. So these service checks are done on both the VLAN and the zone. The manage IP and the manager IP work exactly the same way they have in the lesson on management, as does the username and password. Okay, so how do we set up and configure transparent mode on the ScreenOS firewall? There are some steps involved here. First, we're going to create any user-defined zones we need beyond the built-in zones. Then we go ahead and assign interfaces to those zones per the network design. Then we configure our VLAN 1 interface to have an IP address, picking its broadcast method and the management services. And then we're going to configure the management services on the zone so that we can reach the VLAN 1 interface. And finally, you design and create your policies between the layer 2 zones. So this is the process that's necessary to configure and deploy transparent mode on ScreenOS. Okay, so here's a sample configuration from the manual. In this case, we have a trusted router on the left and an internet router on the right that were previously connected together. And what we've done is we've inserted a ScreenOS device in between the connection that was formerly directly here. So we've inserted this device into this network. The interface domain is 1.1.1.0/24. So that's our broadcast domain. We're operating in transparent mode in. We have a internal router at .250.1. We have an external router at .250, and we've assigned the .1 address as our management IP on the ScreenOS device. And we're using Ethernet 0.1 and Ethernet 0.3 for these connections. So in this case, VLAN 1, we're going to assign it an IP address of 1.1.1.1/24. Our whole transparent subnet broadcast domain is this /24, 1.1.1.0/24. And we're going to enable these management services, ping, SSL, and SSH, to be able to manage the ScreenOS device. So this is our sample deploy of a transparent mode ScreenOS, and in this case we're going to use the V1 trust and the V1 untrust built-in zones. So step one, you might need to create custom layer 2 zones for the operation of the device. These will need to include the VLAN tag that you're using for the device. In this case, normally this is 1. That's the default for VLAN 1. And that's done like any other zone using set zone name, and then we're going to prefix it L2-custom, and the L2 VLAN is 1. In the web interface, this is still under zones, the same place that we saw it earlier, and you're going to create the name of the zone, fill out the form, and select the layer 2 zone from the pull down list, and layer 2 as the type of zone. The second step, just like previously in layer 3 operations, is going to be to put the interfaces into the zones. This will use exactly the same process of interface to zone assignments that we saw previously. So we'll use our set interface command, Ethernet 0.3 into zone V1-untrust, and if you edit the interface on the list in the web interface, you just select the zone name V1-untrust for the interface, and it would be in this scenario. So this assignment is exactly the same as in layer 3 operations. Step 3, we need to start configuring our VLAN 1 interface for management. This is configured like any other interface. So we're going to use the set interface command, name the interface VLAN 1, assign the IP address 1.1.1.1/24, and assign the manage IP to also be 1.1.1.1/24. In the web interface, it's again listing the interfaces and choosing edit next to the VLAN 1, and go ahead and fill out the form for the IP address, subnet mask, and the manage IP in the web interface. Again, this is exactly the same as the procedure you use for layer 3 operations. Now the second set of options we have in our VLAN 1 interface are broadcast options. We can choose between flooding, which is the default, and then our device is going to behave entirely like a normal switch, which means if a packet comes into our switch port and we don't have an entry for it already in our ARP table, we're going to flood the packet out everywhere that we're connected to in order to get it to its destination. And there are no MAC addresses therefore associated with our interfaces because they're all operating at layer 2. The second mode we can use is this ARP and trace route. This is slightly more secure, so it can be used in those situations where you don't want to have standard switch behavior. What it will do is when the first packet arrives to the switch that we don't have an ARP entry, instead of flooding the packet, we'll do a ARP request and an ARP trace route with a hop of 1, so that it can only give us back immediately adjacent devices at layer 2. Once we determine that there is indeed someone there that can answer the ARP request, then the second this enters the entry into the ARP table, and then the second packet and subsequent packets that arrive will be sent to the correct location. This way we're not flooding traffic unless we're sure there's someone who can accept the traffic. So this is configured using the set interface parameters. It's either going to be broadcast flood or broadcast ARP, or in the web interface you're going to choose flood or ARP in the radio button, and then the trace route is optional if you want to use the ARP trace route method. You can do an ARP query, or you can do an ARP query which also including a specific one-hop trace route. The third section on configuring the VLAN 1 interface will be to configure management services. These again are just the same as any other interface, so it'll be set interface VLAN 1, manage ping, manage SSL, etc., or pulling up the edit of the VLAN 1 interface and checking off all the services that we want to enable on the VLAN 1 interface. Management services also need to be configured by the zone. So in this case, we're going to say set zone v1 trust manage SSH, allow SSH on the v1 trust zone. And these will be a property of the zone in the web interface. When you edit a layer 2 zone interface, you get the same service options section that you normally see on an interface at the zone level. And again, they have to be enabled both at the zone and at the interface for the path the traffic is taking to the device. Policies are created exactly as per the normal procedures. So you're going to do set policy from zone to zone, the address objects involved, the service involved, and either permit or deny. And this will apply then to the policies between or intra-zone policies for the layer 2 policies. So there's no difference in configuration at all between creating the permit or deny policies in the layer 2 zones versus the layer 3 zones. So you will need to have your address objects, your services, all the other foundational items created, and you'll follow the instructions just as they were in the policy creation and policy options sessions we had earlier. Okay, so now we've configured our device to operate layer 3 and applied some policies. What are some additional troubleshooting commands we have? In transparent mode, you can still use the standard get interface, get ARP type commands. Now, since we're operating as a switch, we're probably going to be playing more at the ARP level, but you might need to see packets coming in on a particular switch port interface operating in layer 2. You can also use the MAC learning table to see what's happening with the collection of MAC addresses on the device. And you can also still use the session table to see what your policies are up to. So here's our get interface. It tells you the same information that we saw before, that the interface is up and running, that there's no IP address associated with it because we're in transparent mode, and what MAC address is associated with the interface, and the session numbers and error counts and the like. So standard interface, no different than layer 3, other than we don't have a layer 3 address configured on it. Our ARP table will show us what IP addresses are associated with which MAC addresses that the device is seeing transit traffic for, and the general usage statistics. The MAC table will show the learning table that's here, what MAC addresses are associated with what interfaces, and also we can set static mappings. So if we want to make sure that an address is always in the table and doesn't time out and leave, we can do some static mapping of MAC addresses to, say the servers that are physically connected to certain ports or whatever. So when you get the MAC learn, you can see there it just simply lists, the interface, the MAC address, and what the current timeout value is when that'll expire from the table. Sessions. This is again maintaining the totally normal session table, just as we learned about in the previous sessions. So we can use the get session command to see the complete list, or we can hone in on a particular number, ID number. On the web, you're going to go to the same place that we showed earlier in the earlier session. You're going to go into the policy that you want to have check the sessions and the logging on. No changes at all in how to manage and troubleshoot sessions. Design considerations. You must configure a policy for any traffic to be forwarded. There's remember that this is still a ScreenOS firewall. The default is to deny unless it's intra-zone traffic in a trusted zone. So you've got to design and create your policies, or nothing's going to pass through the device. Your policies can reference layer 3 addresses, so you can still use the full policy capabilities for service and IP addresses. As a result, this does prevent any broadcast storms from happening through the device. This is a good deploy option for migration. You might be in an existing data center that's deployed with ACLs on a lot of public servers. This can get a firewall in quickly without having to do a lot of re-IPing or recabling of devices. It can be a quick and easy deploy to get a straight 2-zone transparent mode inserted in line with an existing router and switch. This will be able then to add filtering or VPN connectivity to that existing layer 3 data center network. And it also allows you to test your policy designs before going to a full layer 3 migration. You can implement good part of your policy rules in this layer 2 mode, and the policies themselves aren't necessarily going to change when you pull the firewall up to layer 3. And it does allow those operations where we want to have no natting involved for the public addresses on a server. So by having the layer 2 transparent mode firewall, we can keep the actual public addresses live on the interfaces on the servers. So this has been our session on transparent mode. You should be able to describe the advantages and how the operation of transparent mode works in ScreenOS. You should be able to tell the difference in a zone list between the layer 2 zones and the layer 3 zones that are configured on a ScreenOS device. And you should know how to use the VLAN 1 interface and configure it for management of the transparent mode ScreenOS. If you have any questions about the material presented in this session, feel free to post those in the forum associated with the class. If there's comments or suggestions you have related to the session, they can go there as well. If you're not comfortable with airing your questions or whatever in public, feel free to contact me via the information on the website. I respond to messages as soon as I'm able, and I thank you for your kind attention and taking the time to learn about transparent mode on the ScreenOS firewall devices.